Welcome and thank you everyone for joining us today at the Flash Memory Summit. My name is Gerald Kunstman, and I'm the Intel Ambassador at phoenixNAP. I specialize in working with our clients to build infrastructure solutions leveraging phoenixNAP's IS platforms and the latest Intel technologies. In today's presentation, we'll dive into big memory processing use cases, some of the challenges and limitations we see as it pertains to infrastructure and hardware, technologies we're using today to overcome those challenges, as well as look ahead to the next generation technologies that we're looking at to solve those next generation challenges. Let's start with taking a look at some of the trends we're seeing with data. Many of the activities that drive our day to day is fueled by data. When we look at the global data sphere, we can see massive acceleration in the growth of data generated. The global data sphere is expected to grow to a staggering 180 zettabytes by 2025, and real time analytics makes up approximately 30% of that data growth. Organizations are constantly looking to get results, augment their workflows, and make decisions in ways that are faster, more precise, and efficient. And they are more and more frequently looking for valuable ways to extract insights from their data and are exploring and driving innovation in areas like AI to accomplish these goals. A market that is expected to reach $126 billion by 2025, with finance, healthcare, telco, retail, and technology sectors really leading the charge in that space. In that pursuit, organizations are more and more frequently pushing the upper boundaries of traditional hardware capabilities and are turning to new technologies that can overcome these limitations. Another trend we're seeing is organizations are struggling to keep up with the amount of data produced. Organizations are generating more data than they ever have before, but are struggling to find ways to make sense of that data and find meaningful ways to actually utilize and act on it. In a survey, 38% of the respondents agreed that the complexity and just sheer volume of data produced made it very difficult to generate real business value from it. 97.2% of the organizations surveyed by Conductor say they're now investing in artificial intelligence and big data to help solve those challenges. IDC predicts that global data creation and replication will see a compound annual growth rate of 23% through 2025. So, looking at these trends, they indicate data growth isn't slowing down anytime soon, and organizations will continue to need to invest in tools and infrastructure that help interpret and make sense of the data in ways that deliver meaningful insights and value to the organization. So, what are some of the challenges of processing AI and machine learning workloads? These workloads tend to demand a lot of compute horsepower and resources that may actually exceed the infrastructure capabilities available within an organization. Additionally, AI and HPC deployments can require a lot of power. According to Forcer, power demands increase an additional 30 to 50 kW per rack with these type of environments. That kind of power density requires specialized data center space, equipment, and expertise to both build and manage it. Collecting and processing data is another challenge, especially when we're looking to ingest it from geographically distributed sources. This can add significant complexity in infrastructure, implementation, as well as monitoring. Security is always a concern and challenge, especially when working with sensitive data such as financial details, PHI, or other sensitive information. Scale is another challenge as well. AI and machine learning at scale needs flexibility around capacity, performance, and data retention sources, as well as the ability to rapidly adjust and optimize infrastructure to the ongoing and changing needs while simultaneously maintaining availability and security. Many of the components of AI and machine learning infrastructure deployments require diverse skill sets and staff to properly execute. For many organizations, this can be challenging to provide on-prem. At phoenixNAP, we specialize in building and supporting complex infrastructure solutions, and we also work with great partners like Intel and Memverge to provide next-generation technologies that can help organizations augment their resources and tackle these challenges by gaining access to elastic and highly scalable data center resources, compute security, expertise, as well as access to powerful software and hardware technologies. When dealing with big data, there can be a number of limitations and roadblocks. Price typically is always a factor, right? Throwing additional hardware resources at a problem can certainly be an option, but may not be the most cost-effective solution in every case. Many times, there are options for leveraging software or specialized hardware components that can significantly help a workload more efficiently utilize current hardware resources already available. Budgets in purchasing hardware on a CapEx model can also pose challenges for many organizations when trying to build an on prem infrastructure. Organizations can overcome these challenges and accelerate delivery by leveraging an OpEx model with a cloud service provider that can deliver on all the capabilities they need for their project. Big data also tends to demand a lot of capacity around storage, compute, and network, as well as some other resources, right? Processing data and memory will bring it closer to the CPU and help boost performance. However, DRAM can be very costly, and we may also run into limitations of the underlying hardware's capabilities and capacity. Lack of access to accelerators for AI and machine learning workloads can also impact performance and may result in requiring tedious tuning and other workarounds. Utilizing scalable infrastructure solutions that include the right tools for the workload will help deliver superior performance, accelerate deployments, and deliver significant savings in terms of cost and time. As we know, data growth will continue to explode, and organizations will find hosting big data more and more challenging. And they're going to need to find highly scalable, elastic, and high performance next generation infrastructure services to host and process their big data workloads. As we look ahead to the future of big memory implementations, many of the challenges will be familiar, but there will also be exciting opportunities to tackle them in new and innovative ways. At phoenixNAP, we're constantly working to deliver next generation IaaS solutions to market to help organizations access agile, scalable, and flexible infrastructure, leveraging the latest technologies such as Intel Optane persistent memory, Xeon scalable processors, SmartNICs, FPGAs, and GPUs. We see Compute Express Link and the capabilities and standards it brings as a force multiplier to support us in our effort to help our customers achieve new levels of efficiency, performance, and scale. Heterogeneous computing will also help increase densities and boost performance, while at the same time with CDI, we'll be able to look beyond the hardware limitations of individual systems and instead disaggregate our infrastructure technologies and pull them together to offer our customers infrastructure in a fully composable approach over a CXL fabric. This, of course, offers tremendous possibilities in how we could allocate infrastructure resources, such as Optane persistent memory, GPUs, FPGAs, and others, as well as achieve vast efficiency gains by eliminating purpose-specific hosts and instead use generic purpose hosts that can evolve on demand into specialized systems by being able to rapidly attach these memory, GPU, and other accelerator resources. When it comes to big data, we won't be limited to building memory infrastructure solutions at the terabyte scale, but instead this kind of technology will enable us to build petabyte scale memory solutions. At phoenixNAP, we do a lot under one roof and deliver a diverse portfolio of infrastructure solutions, including colocation, hardware, network, as well as cloud services across data locations in the United States, Europe, and Asia. Our flagship infrastructure solution is our Bare Metal Cloud platform. Bare Metal Cloud is a cloud-native, API-first platform for deploying true bare metal servers, leveraging the latest hardware and software technologies. Composability of infrastructure has been a main focus for Bare Metal Cloud since its development. Our clients can deploy bare metal infrastructure on demand via API, CLI, and dozens of IAC tools. Since our clients have access to the metal, they also have access to underlying hardware features and accelerators, allowing for highly optimized workloads. In collaboration with Intel and MemVerge, we've launched a big memory instance type in our Bare Metal Cloud, leveraging Intel's Optane persistent memory, as well as MemVerge's memory machine virtualization software, which provides our clients with the ability to rapidly deploy and scale big memory infrastructure while also reducing complexity and accelerating go-to-market. We are rapidly developing and releasing new features and functionality for Bare Metal Cloud. Today, clients can deploy dedicated servers via code in minutes versus the traditional timeline of hours or days, or maybe even weeks or months. Today, we have over 47 instance types, including the latest generation Xeon scalable processors, as well as other Intel Xeon platforms. We support a wide range of popular operating systems and have also built dozens of custom plugins for popular infrastructure as code tools, including Ansible, Terraform, and Pulumi for automated infrastructure deployments for our clients. We also have our repos and SDK available as open source, and they're available on our GitHub page. Bare Metal Cloud has flexible billing models, including hourly billing, as well as reservations for longer-term projects if that's needed. So this is just a small list of some of the core features that are available in Bare Metal Cloud. If you'd like to learn more about the phoenixNAP Bare Metal Cloud platform, please reach out to us and we'll be happy to set up a meeting to discuss the different features and solutions that we can help build for your next project. We are also an Intel launch partner and deliver the latest Xeon platforms and technologies in our Bare Metal Cloud. Because we're delivering instances as bare metal, we also have the ability to expose and give access to many of the underlying hardware features and technologies, including things like Deep Learning Boost, AVX 512 instructions, Intel Software Guard extensions, as well as Optane technologies. We work with a lot of projects that have unique challenges and help build specialized infrastructure solutions for our clients. One of the areas we're seeing challenges in big data is in health and life sciences and pipeline workloads that require large amounts of memory, and in many cases can actually exceed the available capacity of the systems. We were able to solve this challenge by utilizing Intel Optane persistent memory and Memverge's memory machine software to virtually pull together and manage Optane memory and DRAM to deliver the memory capacity the client needed. TGen came to phoenixNAP with a unique challenge to optimize and accelerate performance of their single-cell RNA sequencing pipeline. TGen is a nonprofit that does amazing work with precision medicine and translational medicine, focused on research for cancer, diabetes, neurological disorders, and rare childhood disorders, using genomic analysis and sequencing. This analysis involves very large matrices and results in large data sets that are constantly growing in size and causing analysis to take exponentially longer. Working in collaboration with our partners at Intel and Memverge, we were able to build an infrastructure solution leveraging Intel Optane persistent memory as well as Memverge's memory machine software to create several optimizations to their workload. The Memverge team was able to help provide code that utilized memory machine snapshot capabilities, avoiding serial processing of the workload, and instead create multiple paths that could be run in parallel. Additionally, this feature allowed TGen to avoid writing the analysis results to disk and dramatically reduce runtime. This solution delivered a 36% increase in their single-cell RNA sequencing performance, and they were also able to dramatically improve their splatter analysis from 2 months to just 13 days. With that, I'd like to thank everyone for tuning in. If you have any questions or if you'd like to learn more about the different big memory infrastructure solutions we can provide, please reach out and we'll be happy to set up a meeting with you to discuss your next project.